Good day. My name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. Our previous lesson was on transition from descriptive statistics to inferential statistics. That includes the calculations as well as the rationale in why we had to have those values so that we will be able to move from descriptive statistics to inferential statistics. Another discussion that needs to be shared is on true data. The key element in research and research statistics is variation, and that variation has a numerical value, that is the standard deviation. The aim, all of everything that has been discussed, is on true data, from sample size to Shapiro and Wilk. First of all, in sample size, it has to be of heterogeneous mixtures, simply because the need of variation. If there is variation, there's an assumption that the data set will be normally distributed. In fact, in reliability, the higher the standard deviation, the higher the probability for the data to be reliable, and as discussed before. All of these statistical measures are countermeasures to ensure that the data is of heterogeneous mixture in order to fit a condition to be able to go to inferential statistics. The analysis of the sample can be inferred from the population, as well as having the data set to be approximately distributed and make use of the probability value. Thus, though there might be a temptation to manipulate the data because it's too personal for the researcher, it is a contradiction to the entirety of the topic discussed. And it will not prove beneficial in the long run if you try to manipulate the data because it's too personal for you and you want it to be successful. That's not how it goes. Okay, so you have to be true to your data. In addition to the concepts of missing data, mortality, and data by face value seem to be answered frivolously by the respondent, this can be solved by adding three to five more respondents in your sample set. The data can be used to replace, in case of missing data, mortality, or frivolous responses. The conditions when the condition when using inferential statistics are sampling. Sample should be based on calculation. Selection of sample should be of heterogeneous mixture and randomly selected. In t-test, distribution of responses per group. This means that I'll show you that later. A more specific example, but as for now, I need to discuss this one. So in t-test, that's inferential statistics, approximate distribution of responses per group. Where, for example, we're doing group A and group B. This means the number of responses of the first group is same, is the same, or approximately the same with the number of responses to the second group being compared. Condition number three is relative. When we say approximation, means that the first group should not have more than 40% than the second group, or vice versa. Condition number three is critical and should be followed. For example, the first group and the second group has the same number of responses. That's good. We can compare group A and group B, same number of responses. If the first group has 8 responses and the second group has 12, can still consider it approximately fair to compare. However, if the first group has 13 and the other has 7, it is no longer fair to compare the groups. The groups being compared is no longer approximately equitable. So, for example, you have group A, group B, same number of respondents, same number of responses. Good, we compare. The second scenario is group A, group B. Group A has slightly more, or group B has slightly more. We can compare. But when it's too much, that group A versus group B. The remember that cal- the computer will calculate and give you a result, but is it really fair to compare the responses of group A, which is significantly higher than the responses in group B by value, not by response, but the number of the responses is significantly higher, and it's no longer fair to compare. You'll see that soon, later soon. So, but remember, it will still calculate the data, and it needs the researcher for have that knowledge and that consideration that this is no longer fair. Like comparing 10 students, the performance of 10 students versus 2 students, no, even 3 or 4. So it has to be equitably distributed, not necessarily the same, but equitably distributed. A normal distribution based on calculation. So there is a critical. This is critical for the use of probability value to infer to larger population. The problem here is could arise if, based on calculation, the data is not approximately distributed. Even if conditions 1 to 3 are met, the solution is simple. Do not use the probability value in testing hypothesis. Limit your insights to the group being studied and do not infer results to a greater population. So you have your data and you were honest. Like they fit to 1 to 3, the conditions 1 to 3, and you are certain that the data are true. But when you calculate for normality, it's not normal. It didn't fit the condition. So are we saying that we're gonna throw away our data? Not necessarily. You can just do not use the probability value. You can use the other results, the mean, standard deviation, and other results within the data, but do not use the probability value because it is the probability value that is connected to the normality within the table. So limit insight to the group being studied. Do not infer results to greater population. F-test and t-test can provide other information that can be used in studies, such as mean, standard deviation from each group, and differences of the mean. Those are descriptives and are sufficient to describe the study. So don't be like concerned or overthink or anxious that I have to manipulate my data because it has to be normal and so that I can do inferential. Keep it as it is. Be as honest as you can, and if by chance it's not normal, then just don't use the probability value or infer to a larger population. Describe the data as it is, descriptively, even though you're comparing means and standard deviations and stuff. So in addition, there are statistical tools that can be used in the case if, if data does not follow the conditions of normal distribution, such as contingency table that can provide descriptive analysis with intercepting data. You will have data probability and chi-square. So there are other tools that you can use in the case that data are not normally distributed. And these are those tools. I think it will be discussed in the end part of the book. But most important, the basic concern as a researcher or as a panelist or a data analyst is that the data has to be true. And sometimes I've seen this a couple of times. The researcher tends to be too personally attached, and sometimes there are missing data, and they just put and you can see the pattern of repetition and the probability of the same responses. And I've seen it, and sometimes laziness in coding, they just put the same responses. So and also responses from the respondents themselves that they just answer it lazily. So those are the things you need to consider. I think you already discussed those points here. And so when you do your research, make sure your data are true. I will end this video for, I will end that because I think that's a very important concept. And we will be moving to inferential statistics, some tests of difference and F test, T test and F test nova in a while. So thank you and have a good day.